Okay, we will learn how to draw the free body diagram of this beam. Now, what is the sign convention we are following? All the forces acting downwards positive, all the forces acting upwards negative, all the forces acting towards the right positive, all the forces acting towards the left negative, clockwise moment positive, and anti-clockwise moment negative. So, in order to draw the free body diagram of this whole beam, we will consider individual parts. First, let us take the portion DE. Consider the forces acting. Here I have written all the forces known in blacking and the reactive forces I am going to draw in with the help of red color. So this is acting towards the right. So let us assume there is a reaction. Let this reaction be HD. Now 5 is acting downwards. Let us assume a vertical reaction which is equal to Vd. Okay. So now we'll use the equations of equilibrium. First, let us take sigma v equal to 0. Vertical forces are Vd and 5 kN. 5 is acting downwards, so plus 5. Vd is acting upwards, minus Vd. No other force, so equal to 0. So you can write Vd is equal to 5 kN. You have got it as positive, so what you have assumed is correct, upwards. Now let us take sigma h equal to 0. Now when you take horizontal forces, towards right positive 10, towards left negative, minus hd equal to 0. So hd is equal to 10 kN. What we have assumed is correct, so you have got here positive, that is this is acting towards the left. Now let us take sigma m about d is equal to 0. Now let the reactive moment at this portion be md in the anti-clockwise direction. So now I'll write the equation of equilibrium. Sigma md is equal to 0 by taking moment of all the forces about d. Now when you take moment of all these forces about d, actually this distance is given as 0.3 meter. So what is the moment of 5 kN about d? Clockwise, 5 into 0.3. Now what is the moment of 10 kN about d? This is acting through d, so no moment. Moment of hd is also acting through the point d, so no moment. Vd is acting through the point d, so no moment. Moment equal to 0 since the moment m is 0. Now moment md minus, because we are taking anti-clockwise is negative, minus md is equal to 0. So you'll get md is equal to 1.5 kilonewton meter. You have got it as positive. That means what you have assumed is correct. The direction is anti-clockwise. Okay. Now you consider this portion DC. This is portion DC. So there will be reaction. Here you have got Vd. Now we can write the known forces. Vd is equal to 5 kilonewton. What is Hd? Hd is equal to 10 kilonewton. And md is equal to 1.5 kilonewton meter. Okay. Now I can draw the known forces in blacking. This is equal to 5 kilonewton acting downwards. Since it is acting upwards, the reaction will be downwards. This 10 kilonewton is acting towards the left, so the reaction will be towards the right 10 kilonewton. This moment at MD is anti-clockwise, so the reaction will be clockwise 1.5 kilonewton meter. Okay. Now this distance is given as 0.6 meter. Now here also I can write the equation of equilibrium. Sigma V equal to 0. When I write sigma V equal to 0, vertical forces 5 is acting downwards. Then I have to assume the reactions. Let this reaction be Vc and let this reaction be Hc and let the moment be MC. Okay. Now let us write 5 is acting downwards, so positive. VC is acting upwards, so minus VC equal to 0. So you will get VC is equal to 5 kilonewton. What we have assumed is correct, so you have got it as positive, so plus. So now you can write sigma H equal to 0. When you write sigma H equal to 0, what are the forces? Horizontal 10 is acting towards the right, HC we have assumed towards the left, so minus HC equal to 0. So we'll get HC is equal to 10 kilonewton. You have got it as positive, so what we have assumed is correct, towards the left. Okay, now let us consider sigma m about C and write the equation. This 1.5 kilonewton meter is acting the clockwise direction, so plus 1.5. What is the moment of 5 kilonewton about C? It is 0 because it is acting along C. What is the moment of 10 kilonewton about C? This is producing a clockwise moment. This 10 kilonewton is trying to rotate this momentum in the clockwise direction. Okay, so plus 10 into 0.6. Now this MC you have assumed it as anti-clockwise. So minus MC equal to 0. So you'll get MC is equal to 1.5 plus 6. So this is 7.5 kilonewton meter. You have got positive sign. So what you have assumed is correct. That is, this is in the anti-clockwise direction. Okay. Now let us write these forces. You have got VC is equal to 5 kilonewton. You have got HC is equal to 10 kilonewton. And moment MC is equal to 7.5 kilonewton meter. Okay. Now let us draw the non-forces, reactive forces here. MC is anti-clockwise. So at this point C, this will be clockwise. 7.5 kilonewton meter. VC is acting downwards, acting upwards. So at this point this will be acting downwards, 5 kilonewton. HC is acting towards the left. So at this point this will be acting towards the right, 10 kilonewton. Okay. Now you have to draw what are the reactions. This is a hinge. So at the hinge there will be two reactions. What are they? VA and HA. Now this is a roller. So at the roller the reaction will be acting upwards. So this is a roller, and at the roller end the reaction will be acting upwards. So let this be VB. This distance is 2 meter and this is 3 meter. Okay, now let us write sigma V equal to 0. VA plus VB equal to 5 kilonewton. We have two unknowns, so we will not be able to find out this one. Now let us write sigma H equal to 0. HA is equal to 10 kilonewton. So HA is acting towards the right, so plus 10 is also acting towards the right, so plus equal to 0. So we will get HA is equal to minus 10 kilonewton. So what we have assumed is wrong here. HA is acting towards the left. So I can write here HA acting towards the left. Now I can mark here this is acting towards the left. HA is acting towards the left. Okay, so HA is equal to 10 kilonewton acting towards the left. Now these are the unknown forces we have to find out. VB, VA and HA. Now let us take moment about B and equate it to 0. Sigma m about B is equal to 0. So what are the moments? This moment of HA about B equal to 0, moment of VB about B equal to 0, moment of 10 kilonewton about B equal to 0 because the line of action is passing through B. Now what is the moment of VA? VA is producing a clockwise moment. This VA is trying to rotate this momentum about B in the clockwise direction. So this is plus VA into total distance is 5 meter. Okay. Now this clockwise moment. So plus 7.5. Then 5 is acting downwards. This 5 is trying to rotate this momentum CB about B in the anti-clockwise direction. So minus 5 into 3 equal to 0. So we can write VA is equal to 15 minus 7.5 divided by 5. That is 7.5 by 5, which is equal to 1.5 kilonewton. You can find out VB. VB is equal to 5 minus 1.5. This is equal to 3.5 kilonewton. So this is acting upwards. We have assumed correct. VA is also acting upwards. Now we can mark the forces VA and VB. So now you can draw the free body diagram of this B. So all the free body diagrams in this subject will be drawn in this manner. So be thorough how to draw the free body diagram by doing the assignment questions. Hope all of you understood what we have learned today, free body diagram. Thank you very much.